All right, welcome back. So, no camera. I know how much people want to see me suffer because this is going to be mathematics for machine learning. So, if I had the camera on, you might see a tear or two. The reason I decided to do this one is I read Situational Awareness by Leopold Aschenbrenner, and he outlined the next 5 to 10 years of machine learning and AI and what that's going to look like. And I was pretty well convinced that that it's going to at some point turn in by 2027. It's going to start getting out of control. By 2030, 2035, it'll be a multi-trillion dollar industry, and governments all over the world will be doing anything they can basically to secure it, to research and develop it, to implement it. It's really going to change the world as we know it, and it's going to be one of the leading industries. Is the prediction made in this? So I want to stay ahead of that. One of the things I might have talked about before on this channel is I feel like I was left behind by cloud. And I don't want to make that same mistake again with AI. So, all right. So, yeah, any pre-exposure to I think can help with learning. Of course, unlearning bad information is hard. Harder than learning good information new. I think, in my opinion, I don't know. I don't have the research for that. But let's continue with this book. I think is perfect. So um, we're gonna pull it up in here, and we're gonna read page 6, which is still part of the foreword. All right. So on page 6, we have the table of symbols. These are mathematical symbols, and the typical meaning for these symbols are described. Now, that word typical is kind of interesting because I guess that meaning could be different, but let's just read the symbols. So we have the first set of symbols is the letters A, B, and C. And then we have special symbols that I have not really seen before. I think these might be Greek letters. Let's ask the AI what these symbols are. So we're going to say, provide a brief explanation of each of these symbols. For each of these symbols. And I just got a new keyboard, and it's a little bit. It's not as good as my Warmier. I really like the Warmier, but the problem with the Warmier is it broke. Yeah, so they are Greek letters for sure. So let's see what the Greek alphabet is. Okay, so uppercase and lowercase. So yeah, you got to know the. So it's alpha, beta, gamma. So C is like a Y, and then uppercase C is like an R basically. So it's a whole nother alphabet. It's not going to translate exactly, but yeah, so we can see how close these symbols are together. If anyone's done network engineering, they know the difference between a 1 and an L can cause all kinds of problems on a network device, and is impossible to detect basically in some fonts. So it's going to get interesting. All right, so okay, so let's stick to the book. I don't want to go into too much detail. So these are scalars, and they're lowercase. Vectors are bolded and in lowercase. Matrices are bold in uppercase. This means a transpose of a vector or matrix. This means the inverse of a matrix. Now, we don't know if this is a capital A from the English alphabet or from the Greek alphabet. I guess it's safe to assume that it's from the English alphabet because it says A, B, and C. Whereas the Greek alphabet doesn't have a C. It has an A, B, and then something that looks like an R, but it's gamma. So it's alpha, beta, gamma. Okay, so let's have it tell the English. Tell me the British alphabet. I know the English alphabet. I know it backwards. Z, Y, X, W, V, U, T, S, R, Q, P, L, N, M, L, K, J, I, H, G, F, E, D, C, B, A. And forwards. A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z. But I wanted it to put it in the same... Put it in the same... table-like format as you did with the Greek alphabet. It's gonna not do that. Oh, here we go. Include a column for name. Oh, this is kind of cool. Yeah, so this is cool. This will probably help a lot with non-native English speakers. Although I, this could be I, yeah. But this is what I was looking for. Cool, and it bricked itself trying to do that. But it did what I asked, which is awesome. Although what I asked appears not to be as useful as I thought it would be. All right, and I'm going to pause it. I'll be right back. All right, I'm back. Let's keep reading the book. We've got plenty of time. So, okay, so there we go. So we read about the inverse of a matrix symbol. We know that it's the letter A with a negative 1. So the next one is the inner product of y and x, which would be paren x comma y. The next one would be the dot product of x and y, and I'll need to get a refresh of these because I'm not from I forget some of these symbols. Sound familiar, but okay. So this is x subscript or x raised to the t times y. Next one is a ordered tuple. Next one is a matrix of column vectors stacked horizontally, then a set of vectors unordered, integers and natural numbers respectively, n-dimensional vector space of real numbers. I'm going to highlight this table. This probably isn't the best way to use the table, just to read it. So I'm going to highlight it, and now we show that the table of symbols shows up as a highlight, so I can skip back to it really easily. So I think that's a better way. I think I'll briefly read all of the typical meanings, which will take a while, but I'll try to get through this a lot faster because this isn't the right way to use a table. I think the right way is when you see a symbol, you skip back to the table of symbols and you look up like what the symbol is and try to understand it. So just wasting time, spending too much time here. So let's move through this faster. So we've got an ordered tuple. We've got a matrix of column vectors stacked horizontally. We've got a set of vectors that are unordered. We've got integers and natural numbers, respectively. We've got real and natural numbers, respectively. We've got n-dimensional vector space of real numbers. Then we have another section. It's not clear why this is placed in another section, but we see the symbols do look quite a bit different in this section than they did before. So the first thing we have in this section is a universal quantifier for all x. Then we have an existential quantifier. There exists x. Then a is defined as b. Then b is defined as a. Then a is proportional to b. For example, a equals constant times b. Then we have function composition, g after h. Next is if and only if. Next is implies. Next is sets. Then we have a is an element of set. And I got to be careful here because this is not a. This is from the Greek alphabet, I think. Oh, no, it is a. See how hard that is to tell the difference between these two? So it is a. So a is an element of set. And now we have a symbol that we haven't had before. So I don't know what symbol this is, but this we can see clearly this is not the symbol a. This here would be the symbol uppercase English A. So maybe it's uppercase alpha? It's unclear to me what that symbol is. So let's actually do a brief, okay, so we're gonna do like this. And I'll finish reading this out. So there's just two more entries. Second to last is, oh, I forget where I was reading. I was reading here. So we've got sets. We've got a and it is an element of set. This is where I was reading because I don't know what this is. We'll find out later. Then we've got an empty set. Then we've got blank without blank, and we'll fill in the blanks later. The set of elements in blank, but not in blank 2, which is not the same as blank 1. Then number of dimensions indexed by this is English lowercase d equals 1, comma ellipses comma uppercase English d, I think, and then number of data points indexed by n equals 1, comma ellipsis comma capital N. So it gets tricky, right? It's mathematics. You have to get it right. If you just make assumptions and the assumptions are wrong, you have to unlearn those assumptions and you have to teach yourself why those assumptions were wrong. So really your best bet is to not make those assumptions in the first place and to just get it right on the first try so you don't have to unlearn things. So let's try to do that. So the question I'm going to ask is, it's unclear to me what is meant by the symbol blank. Is unclear to me what this symbol is. It is unclear to me what the symbol that appears similar to the symbol A, the symbol uppercase A, actually is in the statement in the second screenshot. Oops, and I showed a private chat. That was bad. Okay, so it is unclear to me what the symbol that appears in okay. is it actually meant to represent an English capital A, or is it something else, such as a Greek capital alpha, or some other representation specific to mathematics? The symbol that represents the capital A. Oh, it's Latin. Oh, an uppercase Latin. Okay, so are we talking about three different alphabets here? We're talking about the English alphabet, the Latin alphabet, and the Greek alphabet when it comes to writing mathematical symbols, or do I have that wrong? Okay. So this is important to know. There are three primary alphabets in mathematical symbols. There's the Latin alphabet basically is the English alphabet. Yeah, there's the Latin alphabet, which is the English alphabet. Then there's the Greek alphabet, and then there's symbols that don't belong to an alphabet. Okay, so is it fair to say that the Latin alphabet is the exact same as the English alphabet? Okay. All right, so there's only two. Okay, so there's only two alphabets used. That makes things simple. But there are definitely symbols used that don't belong to the alphabet, of course. And then, of course, there's a lot of numbers, right? And then there's, like, special symbols like a dot and, like, all of these sorts of, like the sign for pi, so. Yeah. Okay, cool. So yeah, that's that set. So now we've got another set of these. This would be a good question for the AI as well. Let's get a question about that. So, or let's get an answer to that. So what we're gonna say, we're gonna take this whole screenshot, and we're gonna say you can see that these are. So we're gonna say in the screenshot, you can see that the mathematical symbols are divided into three sections. Why is this so? What is the commonality of the symbols? What is the commonality and differences of the symbols that warrant their belonging to one of these three sections? All right, so the first section, we have variables and notations for scalars, vectors, and matrices. The second section, we have operators and special functions. And then the third section, we have special symbols for dimensions, data, and calculus. So that's good. I think that really helps. So let's put that in there. So let's highlight the. We can make a highlight, I think, of so we can highlight text. Okay. Now, actually, there are four sections. What is this? Tell. Okay, so actually, there were four sections. Which section is this? Okay, so statistical, probabilistic, and optimization related symbols. So let's add that there because I think that'll really help. So, okay, so what can I highlight to add it there? I guess I'll highlight the first of each. So let's add a note. And we're going to say first section. Perfect. Yep, so note, and then it would be nice to see the note, but that might be a bit much to ask. Oh, now we can see it. Okay, so first section, variables and notations for scalars, vectors, and matrices. Good. So now let's so now see what we can do. So like if we're reading the book and we know they're talking about that, we can skip right to the section, not just to the whole table, right? So that's going to be really helpful. Okay, so let's add a note here. So this is a section, which is operators and special functions, assuming that this isn't a hallucination. If it is, then we'll have to unlearn this, which is going to really set us back. All right, here's the third section. Add a note. So these are special symbols for dimensions, data, and calculus. All right, and then we got a fourth section here, so we'll highlight that and add a note. All right, and then the fourth section. Statistical, probabilistic, and optimization related symbols. And we'll match the casing of the other ones just because. Looks good to me. All right, I like that. So, okay, so we finished reading section 2, so let's read section 3. Section 3 is special symbols for dimensions, data, and calculus. So we've got identity matrix size of m times m, matrix of zeros of size m times n, matrix of ones size m times n. So we can see how that works out there. So this represents a matrix, and then we see how the symbols change down there. Next, we've got the standard slash canonical vector, where I is the component that is 1. Then we have the dimensionality of vector space. Then the rank of matrix A. And notice it's a different kind of A than is up here, which is maddening. So it could be alpha. I'm not sure what the difference is. Then we have the image of linear mapping, which is, I think that's theta, right? I don't know what that is. We'll get an explanation. We'll run this through ChatGPT. We could ask it right now because it's loaded in. So what's the difference? So when it says rank of matrix versus A is an element of set. So notice how rank of matrix and what else? A is an element of set. Have differently formatted letters that both look as though they are the uppercase letter A in the Latin alphabet. Why is this the case? Why can't they be formatted the same? Yeah. So, okay, so in mathematics, italicized letters like A are well, we don't know that this is A. It could be alpha from the Greek alphabet. Are typically used for variables or unknowns, whether they represent numbers, matrices, or other mathematical entities. And then upright Roman letters are used for standard functions or operators with specific predefined meanings, or are typeset in this way to avoid confusion. Good luck with that. All right, so case-by-case formatting to avoid ambiguity. In rank of matrix, yeah. So rank of matrix, let's look at that again. That's this one. So for that one, okay, so you're talking about something else. So so let's write that up. So so it's a matrix, right? Yeah. So yeah, let's read that out in full. So this would be A is a element. So lowercase a is an element of set a symbol representing a specific set, right? And then this is a symbol representing a specific set. But this down here, rank of matrix, and it appears as though they're the same, but they are different. This is no longer a symbol representing a specific set. In fact, it's not a set at all. This symbol now represents a matrix, and it's a different symbol, so that makes sense, right? So there we go. And typically in mathematics, you're going to have a bold capital, you're going to have a bold italic used for vectors or matrices. So we can see that is the case. This is a matrix, so it's a bold italic, uppercase A from the Latin alphabet, which is the same as the English alphabet, not the Greek alphabet. So it's not an alpha, it's the letter A. And then we have the italic that's not being bold is usually used for sets or constants. So we can see that is the case using here. It's an element of set, and this is an uppercase Latin A, that is not bolded because it's a set, not a matrix. There you go. That makes sense, right? It all makes sense. It's just complicated. All right. So the next one is image of linear mapping, and that's what is the name? Let's get the name for that symbol. Okay. What is the name for the funky symbol here? Oh, sweet. Okay. So the funky symbol here. Okay, it's phi. So what's theta? What does theta look like? Okay. Yeah. Theta is typically used for angles, right? Is theta typically used for angles? Oh, sorry. I screwed up. Sorry, I mean... is that typically used for angles? Yes. Yeah. So the sine of an angle, cosine of... Yeah, okay, got it. And remind me what... Oh. Oh. Okay. Wow. Symbol after symbol after symbol after symbol. Wow, okay, I'm kind of already getting bogged down in symbol after symbol after symbol after symbol. So, like, how can I learn mathematics better? Like, do I have to memorize all these symbols? Do you think it would make sense to do, like, an Anki flashcard deck where I just, like, memorize the symbols? Yeah. Okay. No, because then you know them out of context. You need to learn what the symbols mean in context. And, like, sometimes symbols are reused. Okay, that makes a lot of sense. You have to learn the symbols in context, and like sorry, you have to you have to learn the symbols and the concepts, of course. But you have to learn them in context, right? Like, some of the symbols are like reused for different purposes too, I'm sure. So like just like rote memorization of all the symbols would just mean that like you recognize a symbol and you might accidentally recognize the symbol to mean something different than it does. So it's really about developing the intuitions and understanding the concepts, and the symbols just kind of don't even matter. They're just like a way to shorthand things, which, like, if you're learning things, you probably don't even need to shorthand things right away anyway. Like, you want the extended version so that you don't have confusion. Yeah. Okay. All right. I'm good with that. So, yeah, sounds good. All right, so let's read out the symbols in the third section. The third section are special symbols for dimensions, data, and calculus. So we already read these. I've already read that. So, well, let's read this one again. So this is standard slash... oh, we got here. No, let's read this. Okay, so this is phi, P-H-I. And it's this symbol here. So this is the image of linear mapping phi. This is kernel null space of linear mapping phi, which is a uppercase letter in the Greek alphabet, and we can see exactly which one it is because we have that chart here by ChatGPT. It's very up near the top, but we'll get there eventually. So we should have it, yep, right here. So we can see it's phi, and we can see it's the uppercase version of it. Perfect. Okay, so next is the kernel null space of a linear mapping of phi, a linear mapping phi. I don't know if the of could change everything, so I'm not going to say of. I'm just going to read exactly as it is. Kernel null space of a linear mapping phi, and already we've got a term kernel here that probably means something completely different in computer science. You know, if you've heard of the term Linux kernel, you're probably going to have to unlearn that in this context and learn what it means specific to this context. Next one is span, generating set of, and this is a lowercase, and it could be a Greek or a Latin B. I'm not sure which one. Oh, it's Latin, because the lowercase would kind of look like, so if it were a beta and not a B, it would be a much differently looking symbol. All right, so next is trace of uppercase boldly italicized A, not alpha. Right? Let me verify that. Yeah. Right. Because the Greek would be different. It wouldn't be italicized. Okay, next is trace. So then is the determinant of A, which I'm going to have to learn. I don't know what a determinant is. Next is the absolute value. I'm familiar with that. Or determinant, depending on the context. So got to learn what a determinant is. I have no idea. Next is norm, Euclidean, unless specified. Next is the eigenvalue or Lagrange multiplier. So I've definitely heard of a Lagrange before, but on a very superficial level. There was a juggling pattern named after it. That's all I know. And then the eigenvalue, I've definitely seen that before, but just like, you know, passively watching YouTube videos, I think I've come across it. And I don't know much about it at all. So the next one is the eigenspace corresponding to eigenvalue, and then we have this symbol here. Let's look at our chart of the Greek alphabet. Maybe that is a Greek symbol. Yeah, so lambda. It looks like it's a lowercase lambda. Yep, lowercase lambda. Perfect. All right, and the final section of this table is statistical probabilistic and optimization related symbols. So we've got vectors x and y are orthogonal. We've got vector space. We've got orthogonal complement of vector space. And again, so we have an uppercase bolded italicized letter, which means that it is a variable constant set function, something like that. It's a number, right? Oh no, a set's not a number, right? I don't know. It's a vector space in this case. A vector space, and then the symbol representing the vector space. Next is sum of those symbols there. So this is a lowercase, unbolded, italicized x, subscript lowercase unbolded italicized n, unless it's from the Greek alphabet. I am not sure. Nope, I think it's not from the Greek alphabet. Okay, so colon x subscript 1 plus ellipses plus x subscript capital N. Latin alphabet, italicized but not bolded. So that means that it's if it's from the Latin alphabet, it's italicized but not bolded. And let's save these images because these are really helpful. So let's just capture them and put them in like Paint, and then have them be easier to access. Okay, so that looks good. Let's put it on my Google Drive for my account for this YouTube channel. So we're gonna create a new folder for this series, and it's mathematics of machine learning. Looks good. And then we're going to make a new Google Doc. Okay, and we're going to try to get this out of the way. It looks like we have to scroll down and click got it. Paste that in, and we're going to say Greek alphabet. Okay, and now let's get one more. Let's get another one. But rather than for the Greek alphabet, let's get it for, yeah, so okay, so primary, so we'll say primary types of symbols. Yeah, so let's get that. So let's do a screenshot here. Perfect, and then make a new one. Okay, and then have it the screenshot in there, and then have it say primary types of symbols. Looks good to me, and then we'll make a folder in here called symbols. And then add these to that folder. And there we go. That looks good to me. I think that's a good way to do it. So we'll open this, and that'll be easier to refer to. And I'll have to be referring to that a lot. Believe me. All right, so let's keep going. So yeah, so the next is product of the x subscript colon times ellipses times x subscript capital unbolded italicized n from the Latin alphabet. So I think I know what that ellipses means. That means in a series. So like, for example, 1 plus 2 plus 3 plus 4 plus 5 all the way out to some number, you know. So for example, like, what's 1 times 2 times 3? It would be 6. So you could put so you would be a 6 here. But let's verify my understanding here. So okay, so my understanding of the ellipses, so let's do that here, and let's do a thing. Okay, so my understanding of the ellipses in this screenshot is that it represents a series of mathematical actions. So like, you could have it be like x3, x subscript 3, right? And then that would mean in like a plus sign, ellipses, plus sign, out to x subscript capital unbolded italicized n, that would mean 1 times 2 times 3, and that would equal 6. So x subscript 3 in that case would equal 6. Am I understanding that right? I'm close, but I'm not. They do represent a series of terms, so I got that right. But yeah, okay. I feel like just as long as I'm right that they. Okay, I think just as long as I'm right that they do represent a series of terms, I'm satisfied with my understanding. So I think I'm good there for now. Do you agree? Is there anything I absolutely have to know before, like, moving on and working with my set of knowledge that I have? Yeah, yeah. Okay, so I do have a quick reminders. So uh, so let's save this as well because this could be important. Okay, and then we're going to go in here, create a new Google Docs. I'm going to call it ellipses. Elipsis. I don't think that's how it's spelled, but I can get the spelling from the output here. Oh, there's two L's. Because of course there is. Okay, capital E just for consistency. There we go. I think I'm going to need that later. But for now, I won't even read that. I'll just have it set up for later. All right, so next is the parameter vector, and notice how confusing this is. Now we've got theta here, I think, or we've got the symbol used for angles, meaning a parameter vector now, or at least one that looks like it. I can't tell if it's the same or different. It could be bolded where otherwise it would not be. Then we've got the partial derivative of f with respect to x, total derivative of, and again, this is not an f, right? Like what does the symbol f look like? Well, we can see it in some of the other text, right? So like the word for or of has an f in it, right? So like down here we've got the word of, so we have an f. Does that look like this symbol up there? Do they look the same? No. So this is not an F, and you have to be careful to know that and to say that, because otherwise you're going to be trying to do mathematics with the letter F, and F doesn't do anything. It's not relevant to the context or anything you're talking about. So partial derivative of function with respect to lowercase with x, which is lowercase italicized and not bolded. So if it's in the English alphabet, whether it's uppercase or lowercase, it's used in mathematics, and it's typically used to represent variables, constants, sets, functions, and more. So, and it's different. The uppercase often represent sets, matrices, or specific constants, but the lowercase typically represent variables or elements within sets. So this is a variable. So partial derivative of a function with respect to x. So is it fair to say that, yeah, and then this is total derivative of a function with respect to x. So let's ask the ChatGPT about that quick. To a variable, and let's unpack it and ask if we unpacked it correctly. Okay, so unpacking one of these statements, I would say, colon, quote, and what I would say is total derivative of a function with respect to a variable. Would I be correct in saying that? Or am I demonstrating a misunderstanding? And let's spell derivative right, because we don't want to have it fixate on that. All right, let's see what it says. So it says, oh, okay. Okay, so I'm not right when I say total derivative of a function. So tell me more clearly what that symbol that looks like an F actually means. Okay, so a more precise way to state it would be total derivative of a function, yeah, with respect to a variable. Okay, so I'm missing this last part here. Accounting for always the function changes as x changes. Okay, so that's important. So it represents a function okay. So let's save this as well. Okay, so if I wanted to save this okay. So let's save this. Let's just save this. So okay, so I'm gonna say I'm going to do that, and then highlight this part. All right, copy that and then save it. Under symbols. In the same folder, we're going to create a new doc. And we're going to say function symbol. And paste that in. Okay, so we're gonna say, would it be fair to call? Okay, so would it be fair to say that that lowercase f looking sort of symbol could be named a function symbol? Yeah. Okay. So there we go. So we gotta know accounting for all ways f changes as x changes. Okay. Cool. Yeah, that was, that'd be good to know. Okay. All right, so moving on. Yeah, so we got the f. So next we got the gradient. Then we've got the smallest function value of a function, because that's fair to say that we saw there. Okay, so let's ask it one more time. Kind of harping on this, but it's important because I got to get it right. Otherwise, I got to unlearn. You know, if you just say like that's a lowercase f, it's like no, it's not. Okay, so okay, so then is it correct to unpack this? Unpack what is shown in the screenshot as this, or does it show a lack of understanding? Okay, and then what I'm going to say is the smallest function value of a function. No, it's not. Okay. The smallest value that the function f of x can take as x varies. All right, let's just add that to let's just add that whole thing and then worry about it later when we actually have to think about it more. So function symbol, and I actually do want to do a highlight of this. So okay, so let's highlight this part. Okay, so that matters a lot. All right, cool. And I don't need to save it. I just need to copy it and paste it there. So perfect. Okay, I think that'll really help. That'll really help. So I'll do a sound check now, almost an hour in, and realize that my sound wasn't recording the whole time, but it was good. I see the recording symbol there, so I feel good. Although I could be running out of disk drive, but then it would just stop recording automatically. Okay, so let's continue. Okay, so smallest value of f, but again, it's not an f of a function as so smallest value of a function as is the smallest value that the function can achieve with respect to x. So as the smallest value that the function can take as x varies. Okay, so let's think about that more. So this would be unpacked to the smallest value of the function given the variation of that f does to it. And yeah, so okay, moving on. The value f subscript star that minimizes the value that x subscript star that minimizes the function note arg min returns a set of values, which is interesting. Yeah, because this is the same thing up here. So why don't they just do f? Why don't they? Okay. All right, the next one is Lagrangian. The next one is negative logs dash likelihood. The next one is binomial coefficient. lowercase italicized n. Choose lowercase italicized k. The next one is variance of x with respect to the random variable uppercase unbolded italicized Latin x. Expectation of lowercase italicized unbolded x with respect to the random variable uppercase unbolded italicized x. Covariance between, let's just unpack all these statements. So covariance between a number and another number. And remember, so we've got so these are that's a primary type of symbol. So a set matrices or specific constant. So a specific constant. So let's just unpack all of these. So a specific constant is conditionally independent of another specific constant given another specific constant. Random variable of a specific constant is distributed according to a representative or element within a set, or to a variable or element within a set, whatever it is. Then the Gaussian distribution with mean, we got a new one, and covariance. I think this is a summation. I have no idea. Then the Bernoulli distribution with parameter this unbolded. See how they're different here? This is not bolded and that is bolded. So that's important to notice, but I'm going to kind of move on for the sake of time and kind of running out of steam. I'm usually good for an hour when doing something really in the details like this. So the next one is binomial distribution with parameters uppercase unbolded italicized Latin n and this symbol, which I think is mu, but so let's look it up. So the Greek alphabet. I think is it tau? Looks like tau. Yeah, I think it's tau, right? I think it's tau. Oh no, it is mu. I got it right. Mu. All right. So binomial distribution is there, and then beta distribution with parameters alpha, lowercase Greek alphabet letter alpha, and then lowercase Greek alphabet letter beta. All right, and then we've got the table of abbreviations and acronyms. So EG means exemplia gratica, so it's Latin for example. It's a shorthand for example. Uppercase G, M, and M is the Gaussian mixture model. Next we have id est, which Latin means this means, and these are easy to get confused. This doesn't mean for example, this means like in other words, or this means, or like therefore, right? So this is what means for example. Then I.D, all in lowercase with a final dot. Independent, identically distributed. Then we've got maximum A posteriori. Then we've got maximum likelihoods estimation / estimator. Then we've got orthonormal basis. Then we've got principal component analysis, probabilistic principal component analysis, row echelon form, symmetric, positive, definite, positive definite. And then we've got support vector machine. So let's highlight this one as well. It'll be important to come back to those. And there we go. I'm pretty happy with how that went. So next is part 1, which is mathematical foundations. So let's stop here because this was a lot of really important work, because we can just go to the yellow, and then we can go back to the table of symbols. So let's move the bookmark here, and then we'll sort by bookmarks. Delete this one here. And now, if we're confused, we can see, we've got variables and notations for vectors, scalars, and matrices. So we can hop back there, and we can see, okay, there's there. So we can look at the symbols, right? And then if we're confused by abbreviation, we can see it there. So I like how it's organized already. A lot of books aren't that clear with their symbols. So this book is really cool. I'm glad I'm doing this. But with that, that's going to be the end of this video. this hopefully things aren't this intense again for a while. But it was important that we took the time with those symbols and was able to go back to that section, was able to clear up some misunderstandings I had. I think one of the most valuable things you could probably do with those symbols is to unpack them, right? Because if you're seeing that symbol for a function and you just say it's an f, it's like, how do you unpack that, right? So you need to be able to identify it for what it is. It's not a lowercase f. It's a mathematical symbol, and what it means is a function that accounts for all ways the function changes as the variable given to the function changes. So that's important, right? If you don't understand that, you're set up to fail. So this was really important. This was a really important video, and we're set up for success hopefully in the next video. So thanks for watching, and see you in the next one.